So as we were finishing in lesson 1-1 part 2, we talked about parallel and perpendicular lines. You saw them on the graphs that we did. Parallel lines have the same slope. Can't see the slope with 3x minus 2y equals 4, but once we graphed it, we saw the slope was 3 over 2. Here the slope with this black line was 3 over 2 as well. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes, which means that their product would be -1. The ones on the previous page, remember, were negative 2/3 and positive 3/2. If you take negative 2/3 times positive 3/2, you get -6 over 6, which is -1. So anytime you have a product of -1, those are going to be perpendicular lines. Okay, so we're going to find the equation of the line that passes through 3, 2, and is perpendicular to the line 2x plus 3y equals 4. So in order to do that, I would need a slope and the y-intercept. That's how I find an equation of a line. So I know it passes through 3, 2. Okay, see if I can get 3, 2 there. Okay, right here, over 3 up 2. There's 3, 2. And then I don't know what the slope is of this line. But since I know this perpendicular line, I could find the slope of it by subtracting 2x from each side and dividing by the 3. So it looks like the slope of this line is -2/3. And that's really all I needed, because then I know the slope of my line is going to be positive 3/2, because my line is perpendicular to this line. So I'm going to use the point 3, 2 as my starting spot, and I'm going to go up 3 and over 2. And then I have my line. So the equation is y equals 3/2 x plus, oops, I didn't find that y-intercept yet, did I? Looks like it's going to be somewhere down here, right? And I'm not sure where. Maybe -2-ish. If I would have drawn it neater, it might have helped. It's certainly not 4/3. That's this line. My line's perpendicular to that. Okay, so what I do then, I have y minus the y coordinate of 2 equals slope, which is 3/2, times x minus the x coordinate of 3. I'm going to use that point slope form again. Okay, so I have y minus 2 equals 3/2 x minus 9/2. Okay, I'm just taking 3/2 and distributing it through. I'm going to add 2, so that gives me y equals 3/2 x. Let's see, I have -9/2 plus 2, okay? -4.5, basically, plus 2. So that's going to give me -1.5. So my equation is y equals 3/2 x minus 1.5, which that makes sense. That I'd be about down to -1.5, okay, for the y-intercept. Actually, it would be -2.5. Right, because that was -4.5 plus 2. Yeah, sorry, -2.5. It looks better. Y equals 3/2 x minus 2.5. Okay, sorry for the sloppiness there. All right, so I found the equation of the line that passes through 3, 2, but yet is perpendicular to this line. So I found the slope of this line was -2/3. So the slope of my line is positive 3/2. That gave me y equals 3/2 x plus, I wasn't sure. So I'm going to use point slope form. Y minus the y coordinate of 2 equals slope, which is 3/2, times x minus the x coordinate of 3. 3/2 times 3 is 9 over 2, which is 4.5. So when I added 2 to -4.5, that gave me -2.5 as the y-intercept. Y equals 3/2 x minus 2.5. Okay, so then we're going to use will be some word problems in 1-1, some application problems, something like this. In recent years, a percentage of U.S. population ages 18 and older who smoke has decreased at roughly a constant rate from 20.9% in 2005 to 18.1% in 2012. Find an equation describing this relationship. So what I'm going to do is kind of use the ordered pair of the time, and I don't want to use 2000, okay? So I'm going to let the number 5 represent 2005, and in 2005 it was 20.9%, and then I'm going to let 12 represent 2012. Okay, here they already did that way. Okay, 12 is what, 18.1%. Okay, so you kind of, when there are two variables, I mean, I'm using X and Y because I'm used to X and Y. They use T, okay, and P maybe for percentage. I don't know, but I'm just using X and Y. They subtracted the Y coordinates, 18.1 minus 20.9. They subtracted the X coordinates, 12 minus 5, and they got what that slope would be. Negative 2.8 over 7 is negative 0.4, the slope of the line. See the points, 5, 20.9, 12, 18.1. We get that right from the word problem, okay? So now what that means is, on an average, the percentage of adult population who smoke is decreasing. That's that negative, okay? In real life, that means something. It's decreasing by about 0.4% per year. To get the actual equation, well, I'm going to have to use that point slope form again. I'm going to say, I guess I'll use the point 5, 20.9, okay? And I'm going to, whoopsies, and I'm going to say y minus 20.9 equals slope of negative 0.4 times x minus 5. Okay, so y minus 20.9 equals negative 0.4x plus 2. If you take negative 0.4 times negative 5, okay, you would get a positive 2. So then if I add 20.9, I get negative 4.2x. I'm sorry, negative 0.4x minus, or plus, I'm sorry, 22.9, which I think is what we got here. Negative 0.4x plus 22.9. I just wanted you to kind of see where that came from. There's my equation. That's going to tell me, you know, if you tell me how many, you know, what year, I'll tell you what the percentage will be. Okay, so for example here, it says the objective is to reduce the percentage of U.S. adults who smoke to 12% or less by the year 2020. Well, let me put 20 in for X and see if that's really going to happen. When I put 20 in for X, negative 0.4 times 20 plus 22.9, the percentage in the year 2020 will be 14.9%. So it looks like continuing at this rate, we're not going to reach our goal of the healthy, you know, campaign. Okay, we're not going to reach that goal. So now, first of all, you know, obviously there's limitations in real life problems. Will smoking ever not exist? Will we ever get to a 0%? Probably not. I mean, if we follow this, it should tell us that there would be a time when we would, you know, get to where y would be 0. But a lot of times the model changes over time. But anyway, that's just an example of where you might use a formula like that. Here, sometimes the data we actually get and we just plot it. This is the cost. This is how we started this unit, right? I was telling you about cost of tuition. In 2000, it was $3,508. These are average annual cost. okay, at four-year colleges. In 2002, the average annual cost was $4,098, just tuition and fees, not room and board. 2004, blah, blah, etc. So again, we'll let 0 equal 2000, 2 equals 2002, 4 equals 2004, etc. Here's the cost. We plotted it, and it looks like I could kind of put a line through there. I'm going to draw something that we call a best fit line. It might not hit every point, but hit as many points as we can with the same number above as below. You know, here I have one below, kind of going through here, then I have one above, right? You just try to do the best line you can. And then we can write the equation of that line, okay? So when I did it, when I plotted the points, it was something called a scatter plot because it wasn't exactly a straight line, but it can be approximated by a linear equation. Okay, so we're going to draw the line that best fits the data and you write an equation for it and try to figure out how much tuition might cost in 2030. Okay, maybe that's when I'm going to have a kid that's gone to college and I kind of want to know. I'm not going to plan for what it is this year because it's increasing. Okay, so we draw the best line we can and we use that to estimate. Okay, so first we're going to have to find the slope. So they chose to use these 2 points, 0, 3508, okay, right here. And in the year 2013, I guess, they're going to use that one, 8893. So they were using the first point and the last point. Okay, I didn't quite go through that, but let's try that. Okay, so they're going to use the first point and the last point, and then they're going to get the equation. So we can find the slope, as we know, by subtracting the y coordinates, subtracting the x coordinates. We get about 414.2. Okay, now we need to find the y coordinate, or the y-intercept, okay? So I would use my, actually I know what my b is. I don't have to deal with that. The y-intercept is 3,508. Okay, so I have the equation. Y equals 414.2 x, or t that we're using this time, plus 3508. So the year 2030, I'm going to put 30 right into my equation, and I think it'll be about 15,934. So that's many years in the future. Many factors could affect the tuition. Like, we know all that, but we use math to at least try to use, it gives a great educated guess at things that are going to happen in the future. It's marvelous. Okay, so that is it for 1-1. Please tune in. We're going to start 1-2 in another video. Okay, so 1-1, I'm sorry that it took 3 videos to get through, but it was a big one. All right, you can start the practice on my math lab if you'd like, the 1-1 practice, and then come to 1-2 later, or you can listen to the 1-2 videos. Okay, have a good day.